Hello and good morning, CTS265, Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP Route course, and this morning's video tutorial is going to be on Chapter 6. We're going to be taking a look at the lone lab in Chapter 6, Lab 6-1, where we're going to be working with NAT. And this is actually a very, very good activity. So let's go ahead and jump in. As you can see, we have our topology on the right-hand side. We've already done all of the basic IP address configuration, so we'll jump in on step 2 here. And so on the HQ router, let's go ahead and configure an IP route, or a default. Let's first do no IP domain lookup. So let's go ahead and configure a default static route. So we'll put our quad zeros in here. And then we're going to say 209.165.200.241. And then we're going to go onto the branch router, and I'm sorry, actually 225 is what I wanted there. 209.165.200.225, so let's pull this guy back. All right, so now let's go ahead and go on to the branch router where we can use that mistake right there. And the branch router here. Let's drop that in. All right, so now the branch router and the HQ router both have default static routes that both point to the ISP. It wanted us to do some pings and it asks if they're successful, and they should be. However, was the ping sourcing from loopback 0, and this is on the branch router, so if I were to say ping 209.165.200.226, and this is the IP address right here on the HQ. So we're trying to ping from the branch router over here to the HQ router's FA00 interface. So is that going to work if I source it from loopback 1? And it looks like we may have had a typo in there. Ping 209.165.200.226 source. Let's make sure we've got this interface on here. Let's say do show IP interface brief. Is there a loopback 0? Oh, sorry. Show IP interface brief. And we've got, so that is a typo, because on the branch router there is no loopback 0. They've got to be asking you to do this from loopback, I'm sorry, there's no loopback 1. They've got to be asking you to do that from loopback 0. So at the bottom of page 5, and this was actually a typo that Mary recognized, there is no loopback 0 interface. So it's loopback, I'm sorry, there's no loopback 1 interface, it's loopback 0. So the pings fail because the 192.168.1, that's an RFC 1918 address. So that is a private address. It is not routable on the public internet. And so as a result, and in this case, our use case here, ISP has no knowledge whatsoever of the 192.168.1.1. So it's not going to be able to find its way back. And that's really what NAT is going to allow us to do, right? So network address translation, and really the premise or the catalyst behind NAT was the exhaustion and depletion of the IPv4, the public IPv4 address space. And so I believe it was right around 1994-95 where NAT was actually created in order to alleviate the issue of the depletion of the IPv4 address space. And so it allows us to preserve the public addresses, where I can have a single public address represent tens of thousands of private internal addresses. So we're going to go to step 3 now, and we're going to configure NAT on the HQ router. And I'm trying to adjust, let's see here. Yeah, we're going to configure NAT on the HQ router, and we're going to do it on the branch router as well. We're going to do it 2 different ways. We'll do it the way that they're looking for here on the HQ router. And there, let's get out of this section here. All right, so we're on the HQ router, and as we can see, we have a NAT pool. So we're going to be using dynamic NAT. We are not going to be using PAT or NAT overload. And as you can see, we have this pool range here of 233 to 237 /29. Now remember that the actual network ID is 209.165.200.232, and that's the net ID. Right? Now we're going to have a single static assignment here for the email server. The broadcast address is 209.165.200.2, whoops, dot, let's pull that guy back there, .239, and our last usable is .238. And so that is going to be assigned to the mail server. So 233 to 237 are going to be used for our pool. So we'd have .233, 34, 35, 36, and 37. Now, a key thing to remember about dynamic NAT is that once we use up 233, 34, 35, 36, and 37, these 5 IP addresses. So if I had 5 other clients back here that were connecting outbound, once these 5 IPs have been bound to an internal address in the translation table, they will sit there for 86,400 seconds, or 24 hours by default. So if the 6th person came into work, and let's say it's your CEO, and he tries to get out to the internet, it is simply not going to work, because these 5 addresses would already be in use. So the use case for dynamic NAT is you don't need connectivity initiated from the outside to the inside, and you have more dynamic NAT addresses, or more inside global addresses in your pool than you do internal or inside local addresses that will need to get out. So again, once 5 people go out to the internet, these 5 addresses are then bound to their inside local addresses. So these inside globals will be bound to the employee inside locals. And so when the 6th employee shows up with his inside local that hits the router saying, hey, I need to get out to the internet, there are no more inside globals available, and he will not get access. So make sure you keep that in mind when you're thinking about what kind of NAT you're going to do. So let's go ahead and let's get this configured. So the first thing that we need to do is we need to identify the address range that we're going to be providing NAT services for. And so you can see here we've got this loopback 0 address on the HQ router for 10.10.10.1/24. So what we're doing is we're actually simulating a single address, but we're simulating this LAN segment here, and we're saying that it's a /24, and we could have up to 254 users in a /24, but we only have one right now, which is 10.10.10.1. But if another one came online, we want to make sure we could handle that. So let's say IP access list standard, and we'll give it a name. We'll just call it HQ_NAT. So let's put a quick remark in here that just basically says NAT Pool 4 10.10. And I already forgot 10.10.10.10.0/24net. All right, and let's say, let's say we're going to permit IP from 10.10.10.0/0.0.0.255, the wildcard mask, and any. Right, so basically, we're going to be matching any traffic. TCP, UDP, it doesn't matter. IP is sort of the all-encompassing option there that's going to grab all traffic, or match all traffic from that 10.10.10.0 subnet. And it looks like I have permit IP. Did I spell something wrong? 10.10.10.0.0.0.255 any. Oh, do I need permit any IP 10.10? Let's make sure we got this right here. I think I may have left out. No, that should be right. Permit, and it doesn't want IP. Oh, Yeah, so I did a standard ACL. I need an extended ACL. I apologize there. So IP access list extended HQ underscore NAT, and it already conflicts. So we'll say no IP access list. Standard copy and paste. Sorry about that. All right, so there we go. So let's rerun that. IP access list extended. We'll drop our remark in here. We'll just cut and paste this back in. All right, so now permit IP from 10.10.10.0, 0.0.0.255, any. So we're going to match everything. And then now that we have the ACL, let's go ahead and create the NAT pool. Now we're going to take a look at a couple different ways to do this. And the first way we're going to see is we're going to go ahead and specifically use the addresses, the usable host IP addresses that are going to be part of this pool. So I'm going to say IP NAT pool, and we'll just call it HQ underscore NAT underscore pool. And then we're going to put the starting address, which is going to be 209.165, 200 dot, and we said 233. Let's double check that. Yep, 233. And the ending address is going to be 209.165.200.237. And we're going to go with the prefix length of 29. All right, so if I were to say do show run, include pool. So there is our NAT pool statement, right? IP NAT pool, HQ NAT pool. Now remember, I've used the usable IP addresses here from 233 to 237, and this is inclusive. So it includes 233 and 237. When I say inclusive, what I don't mean is that it doesn't start at the next IP, which would be 234, and then end at 236. So we're saying we are going to start using 233 and use all the way up to 237, inclusive, including those two addresses. Now, this is one way to do it. From your CCNA studies, you may have remembered sometimes you'll see where they show you the the network ID followed by the broadcast address, right? And if you were to do that, what that would mean is that you want to use all of the addresses in this subnet range. Now, we clearly do not want to do that because .238 is going to be the email server. So that's why here, with this use case over the headquarters branch, we're specifically stating I want to do NAT, but I only want to do it for 233 to 237. That these are the addresses that would be used, this range. I'm going to leave 238 out of it. And remember, I don't have to use every single address here. I could say 233 to 235. Or 233 to 234 if I wanted to, and then keep those other addresses maybe for other static assignments like the 238. However, that's not really required here. We only have one static that we're going to need, and so that's going to be 238. So we're going to use 233 to 237 for the pool. Once those 5 IP addresses are gone, no one else internally is going to be able to connect to the internet off of that subnet right there, 10.10.10.0/24. All right, so let's clear our screen here. And we've got the pool. So now what we're going to do next is we're going to bind the pool to the ACL. So it's IPNAT inside source list, and then what is the name? It's HQ underscore NAT, or actually, yeah, HQ underscore NAT. And then the pool name is HQ underscore NAT underscore pool. Now, it's right here where we have the option. Remember, we're doing dynamic NAT. Okay? We're not doing PAT or NAT overload. Okay? We are not doing either of those two right there. Or we're not doing this one right here, NAT overload, which would be PAT, or port address translation. Now, there is nothing that says that we cannot do PAT with a pool. In fact, we could do PAT, and we're just simply saying these 5 addresses are going to be providing all of the port assignments, so that would give us a pretty substantial number of inside local addresses who could connect to outside globals, right? Using these inside globals that are in the pool. And again, when the overload is in play, we're using port address translation. But that is not what we're doing here. We're just simply doing dynamic NAT, and we're using a pool of addresses. So I'll go ahead and hit enter. So now that we have bound the ACL, do show run, and we'll say section NAT. Now that we've bound the ACL to the pool, or the pool to the ACL, we're ready to go here with our dynamic NAT. However, we still have that one static that we need to take care of. So we're going to say IPNAT inside source static. So it's going to be that last, and actually it's the inside local. Yeah, the inside local address first. So what's the email of servers inside local? 10.10.20.238. 209.165.200.238 was the address that we were keeping on the side. So this is our static NAT assignment, right? So literally, it's a single static NAT assignment for the inside local 10.10.20.238 to the inside global 209.165.200.238. So we've taken care of all of the static and dynamic NAT configuration at this point. The only thing that we have left is to go into the interfaces. We'll start with loopback 0, and we'll say IPNAT inside. And now this may take a couple seconds here, definitely not as long as it did in the discovery activity. So we'll say IPNAT inside, and we're identifying, and this is what's typically called NAT domains, right? The inside domain or the outside domain. And so if I go into interface loopback 1, I'll say IPNAT inside as well. And even in Packet Tracer from your CCNA studies, you may have realized that when you typed in this command, it came back immediately, and that was probably because it's set up to do that. But in reality, it's going to take it a few seconds, not as long, again, not as long as it did in that discovery activity with NAT, but it certainly does take a couple seconds the first time. And then once it's done, the subsequent IP NAT inside statements go pretty quickly. So now let's go into the outside interface, FA00, and we're simply going to say IPNAT outside. Whoops. IPNAT outside. All right. So now that we've got that configured, let's go ahead and do some validation here. So if I were to say show IPNAT translations, you can see we only have a single translation here. And remember that this will always be in the translation table until I remove that static NAT statement, this IPNAT inside source, right? Because it's static, so it will always be in here. And you'll notice we see the protocol, right? As to whatever the protocol might have been, the inside global address, the inside local address. Now there's no outside local, outside global, so let's go ahead, let's test connectivity, and let's see if anything changes here. So let me double check. So yeah, this is the email server. So if I were to say ping, and we're going to ping that loop back up on the ISP, so 209.165.202.129, and now remember, I need to source it from the 10.10.20.238. So I'm sourcing it from the inside local address of the email server. And let's see if we have any success. We do. So the first packet drop, right? Remember, that's our ARP. We got to get off the local network. So it's going to ARP out for the default gateway. And then off we go. So subsequent pings are going to work great. So let's take a look and see if I say show IPNAT translation. Does anything change? Do we see the protocols? And absolutely we do, right? So, and this is the sequence number. And remember, we ping 3 times, so it starts at 0, and then 1, and then 2. And so the protocol is ICMP because it was a ping. The inside global, right? Remember, this is the address that is rewritten in the IP header as it goes out that fast Ethernet interface onto the internet so that people can get, so that other hosts can get back to me. And then here is my inside local. Now the key thing to remember is that it's going to show us the outside local and the outside global. Now, we are not doing NAT up here, right? If we were, the outside local and global could be different if we were NATing again at the ISP, but we're not. And that's why when you look at your outside local and your outside global, they're going to be the same. And so this is the translation table. Let's take a look at the statistics. So I'm just going to say show IPNAT statistics. And let's see what we've got right now. So we have total active translation. So right now we have a single active translation. And is it static or dynamic? Well, we've only got one, so it's pretty easy to identify that this is going to be a static. So the peak number of translations was 4, and that was 1 minute and 14 seconds ago. So which interfaces are participating in domain NAT? And I'm going to refer to this as classic NAT. Now, I don't want to say legacy NAT. And I know that when you did the reading, when we read about the NAT Virtual Interface, or NVI, it kind of gave you the impression that this is sort of like the new NAT, right? And that what we're doing here is legacy NAT, and that you don't really have to do legacy NAT anymore because we've got this new shiny NAT Virtual Interface, new NAT. That is not the case, okay? So real quickly here, to go off on a small tangent, because I want to make sure that I draw the distinction. When you're doing NVI, NVI is used to go from one VRF interface to another VRF interface, okay? And Cisco has a document out, and I will see if I can bring that up here toward the end of the video. But Cisco has a really good document that details when you should be using NAT Virtual Interface as opposed to classic NAT. Again, I'm going to avoid saying legacy NAT because domain NAT and the NAT that we're doing right here, right now with the IPNAT inside and IPNAT outside, that is not legacy NAT. It's just simply that NVI is used for one use case, trying to go between VRF interfaces, whereas classic domain NAT is used when you're not going between VRF interfaces. And the reason for this, right, is if you think about it, you're on the same router and you're trying to go between, you know, maybe this is VRF1 and this is VRF2 and this is VRF3. When you're trying to go between the same interfaces on the same router, remember, with domain NAT, you're saying it's either an outside interface or it's an inside interface. And that is all that domain classic NAT understands. So to try to go from an inside interface to another inside interface and have NAT function, you can't do that, right? It's not going to work the way you think it's going to work. And so that was why we have NVI. Because with NVI, you're simply saying IP NAT enable, right? And so it just simply turns NAT on the specific interface. There is no distinction as to what the domain is anymore. And remember, the domain is inside or outside. And so I want to make sure I'm clear on that because this is a massive point of confusion, and it really wasn't made clear in the Foundation Learning Guide that the use case for NVI is not as a wholesale replacement for domain NAT. It's really for the use case when you're trying to go between VRF interfaces. Okay, and I will definitely pull that document up at the end, but I want to make sure I clarify that because there's a huge misconception that the NAT that we're doing in Lab 6.1 is somehow legacy and that you're really not supposed to be doing it. You're supposed to be using NVI. and that is not the case. Okay, so you can see we had 29 hits. Ceph translated 14 packets. Remember, I think so we pinged, remember, we pinged 3 times, and we had, what was it, the first one missed, and then we had the 4 hits, and then I pinged 2 more times, so 10, or 5 plus 5 plus 4 gives us that 14. Expired translations, it's now at 3. And then again, you can see the inside sources. So how am I identifying my inside sources? Well, I'm using this access list called HQNAT, which I've bound the pool to the ACL. Here's the name of my pool. And again, it shows the name of the pool down here. It shows the net mask. Remember, we use prefix length, but iOS is smart enough to give me the subnet mask for a /29. I've got my starting IP and my ending IP. And so it's just basically a generic pool. I have 5 total addresses, remembering that as soon as the 6th employee gets into work, hoping it's not your CEO, if all 5 addresses are already being used and the CEO tries to go out and he's the 6th, he will not get connectivity. And this is a key point. Remember, the use case on dynamic NAT is you do not need to initiate connectivity from the outside internet, right, into the enterprise to get to a specific IP address, because these are going to be changing, right? They're going to be changing. And remember, the use case for dynamic NAT is that you have more addresses in your pool than you do employees or individuals trying to connect to the outside network. Because once those addresses are used up and in the translation table, they're locked up by default for 24 hours. And if someone came in and logged in and went out to Google and then locked their screen and walked off and went home, that dynamic NAT is going to be locked up. That IP in the pool will be locked up for 24 hours. Okay, so I'm going to clear the screen here. And now let's go ahead and take a look at the show IP NAT translation table now. And as you can see, those 3 translations, that's why it says the expired. By the time we ran this command up here, the show IP NAT Statistics, those guys had dropped out of the translation table. So the translations are gone. All right, so that is working with the static. Now, you're probably asking, well, why don't I see any of the dynamic translations in the translation table? And those dynamic translations would be the ones using the pool. For us, it's going to be when we source from 10.10.10.1. So the answer to the question is, we haven't initiated any traffic yet. Remember, the static translation will always sit in the table. So that is going to be in the table until I remove, and let's go ahead and do that. So if I were to go say no IP NAT source inside static to 209.165.200.238 for the, I'm sorry, I got this, I always get those backwards. 10.10.20.238 and the 209.165.200.238. If I were to do show run, did I miss here? Include static, no IP NAT inside source. Oh, I'm sorry, I got the inside and the static backwards there. So let's go ahead, we'll just remove this wholesale. So we'll say copy and paste. So now when I remove that, let's see if we see a message. Does anything pop up on the router? So nothing pops up on the router. What if I say do show IP NAT translations? As you can see, the translation table is empty. So again, until that statement's removed, do show IP NAT translations, until that statement's removed, this entry will sit in the translation table. So let's go ahead now, let's work with our pool. Let's say do ping 209.165.202.129. Now we're going to source this from our 10.10.10.1, our loopback 0 address. So let's see if anything happens here. And again, we'll run 3 pings. Right, you can see everything worked great, the translation worked. So let's take a look at the show IP NAT translations table now. And there you go. And you can see it also picked up from where it left off. showing you that the number that occurs after that colon, that's a sequence, right? Because the first ones that we had was 0, 1, and 2. So this picked up at 3, 4, and 5, right? And so what do we have? Well, it shows us that we've got an inside local address that's coming out of that off that loopback 0, and then here is the address that's being used out of the pool. Now, there's no coincidence, it's the same address, right? Remember, once the translation is made, 10.10.10.1, the inside local 10.10.10.1 will be bound to the inside global 209.165.200.233, and it will hold on to that reservation for 24 hours. Before it ends up letting go of it. And then you can see this is the outside local and global that we're going to. And again, there's no NAT being done up on the ISP router. If there was NAT being done up there, that's where we would see that these two addresses would be different. But we're not double NATing, therefore these addresses are going to remain the same for the outsides. Okay, so now we've seen how the dynamic NAT pool works. And again, if I had a switch and 5 or 6 hosts, I could ping from all of those hosts up to that 202.129 address at the ISP. And on the 6th host, you'd see he would get no connectivity to the internet. All right, so that kind of wraps up, for now anyway, the branch, or the headquarters router. Let's transition over to the branch router, which is going to be branch R3. Now, we're going to do this a little differently over on the branch router, even though they show in the pool, you can see there the 249 to the 254. We're going to spice it up a little bit here, and I'm going to show you that you can use the network ID as well as the broadcast address. So excuse me, let's go from user exec to privilege exec, we just did, and we'll go into global config. So we're only setting up dynamic NAT here. There is no static NAT to worry about. And the reason I bring that up is because there's no need for us to take into consideration or to account for or accommodate a static NAT address out of that pool range. So we're literally going to be using the entire range over here from 249 to 254. Now these are the 6 usable. So remember, the network ID is actually .248 and the broadcast address is actually .255. So those are the 2 addresses that we're going to use in our declaration here when we create our pool. Our starting address is going to be the broadcast ID, and again, you can do both. Like I said, the use case is, hey, if I'm using all of the addresses in that range anyway, I can put down the network ID and the broadcast ID, and that's going to, iOS is smart enough to see when we put the prefix length in, it knows based off the block size for whatever the prefix length is, what the network ID is going to be and what the broadcast ID is going to be. Right? iOS figures that out. It knows it. And what we're going to see is that the 248 and the 255 aren't going to be used. Because again, iOS knows those are reserved IPs given the specific block size. It will figure that out, and it will say, okay, so what's the first usable IP? Well, it would be 249, so we're going to use that. All right, so let's go ahead and do this again. I'm going to make sure we get the extended access list in here. So IP access list extended, and we'll just call this branch, BRANCH underscore NAT, and we can put a remark in here, and we're just going to simply say NAT ACL for, and what are we doing here? The 192.168.1.0/24 net. And then let's go ahead and match. So I'm going to say permit IP 192.168.1.0, and then we'll use our wildcard mask of 0.0.0.255, and then going anywhere. So we're going to match any traffic coming off of the 192.168.1.0 network. So that's it. That is my do show run section access list. So there you go. There is our access list right there. And again, it's always good to put a remark in there in case someone coming behind you doesn't fully understand what you might have been doing. They can easily take a look at that and say, oh, okay, so this is an ACL that he's going to be using with NAT. So now let's go ahead and get that pool created. So IP NAT Pool, and we'll go ahead and, okay, we've got the context-sensitive help is gone. So we'll go ahead and say, what are we going to call this? I said a branch, and I can't remember what we used, NAT Pool. So we use branch underscore NAT underscore pool, and then we've got our starting IP. So this is where I'm going to say 209.165.200.248. I'm going to use the broadcast address. I'm going to use the network ID there. Then I'm going to come back and say 209.165.200.255. And this, again, this is okay because as soon as I say prefix length, LENGTH, 29, iOS can figure out, and you can see there it created that NAT Virtual Interface for us. And it does this by default, whether we're using NVI or not. And this is a good, I want to make sure I call this out. So whether I'm using NVI or not, on recent code, you'll notice this is 15, well, you can't actually see it there. You can see it over here. So this is 15.3.3 code. These other two guys are 15.1, right? 15.1.4. And I don't remember if we saw, we could check, we'll go back and check. I don't remember if I saw it, but on 15.3, on the more recent code, and I've seen this on 15.4 as well as 15.5, it will do this. And it does it by design, is that it's going to create the NAT Virtual Interface. It creates this virtual interface, whether you're doing classic domain NAT or NAT Virtual Interface, NVI NAT. The only time it uses that interface is when you're doing NVI. So if I had said IP NAT enable on some interface, then we're doing NVI, and then this would get used. This is not going to be used when we're doing domain NAT. However, iOS creates it by default anyway. So let's clear the screen here. And where do we leave off? So we've got the pool created. So now let's bind the pool to the ACL. So IP NAT inside source list, and we called it branch underscore NAT is the name of our ACL. And let me double check that. I can never remember the names of these ACLs. Yeah, branch underscore NAT. So branch underscore NAT ACL. And then what's the pool that we're going to be using? Well, we're going to be using, and I'm looking for, there it is, branch NAT Pool. Sorry. Branch NAT Pool. So we'll say copy and paste. Now remember, if I was doing PAT, which I can do with a pool of addresses, it just gives me more ports to choose from, or more ports, I shouldn't say to choose from, but more ports available to me. And again, if I was doing this with PAT, I'd have to be servicing a pretty large enterprise network with tens of thousands, if not hundreds of thousands, of outbound connections that could be taking place. Because again, we've got 6 IP addresses that we're using, and I'm just going to round down. Each IP could service about 60,000 ports, so we'd be looking at, what is that, 360,000 possible outbound connections that could be serviced if we did NAT overload, which is PAT, or port address translation. But we're not. We're just simply going to say IP NAT inside source list branch NAT pool, branch NAT pool. And again, name of the ACL, name of the pool. And so we're not doing static. This is all we're doing. So do show run section NAT. So there's our pool, and there is the statement binding the pool to the ACL. So just like the other router, all we need to do now is go into FA00 or 01, sorry, FA01 and say IP NAT outside, because that's our outside interface. And as you can see here, it's going to take a second. And then we're going to say interface interface loopback 0 and IP NAT inside, because that's our inside domain, right? The outside domain is the internet facing, the publicly facing interface. And the inside domain is the internal facing interface. All right, so we've got those statements in there. So let's say do show IP NAT translations. What do you think we're going to see? Exactly. We're not going to see anything because we're not doing static NAT here. Even we've been doing this for a little bit here. If I were to go back over to the HQ router and say show IP NAT translations, you can see that we have the two translations that are still in the table over here. And let's see if I were to say show IP interface brief. Yeah, it did create it. I must have missed it when it gave us the message. But the NAT Virtual Interface is created by default. And again, whether we're using NVI NAT or classic domain NAT, with 15 code, you should see this get created auto-magically for you. However, it's not being used when we're doing domain NAT. All right, so let's go ahead and where do we leave off here? So show IP NAT translation. So let's generate some traffic. So do ping to 209.165.200 202.129, and let's source it from our loopback 0 address. Now we should probably have a failure on the first packet and then success, right? So we'll do 3 pings here, and then let's go ahead and say show IP NAT translations, and there we go. So we've got our translations in the table now because we've generated that ICMP traffic. What if I were to try to, let's see if we can change this up. So if I were to say, let's see if it goes out, telnet to 209.165.202.129, source it from loopback 0. Yeah, it doesn't like that. So show IP NAT translations. Does it even pick that up? No, it didn't even pick it up. Doesn't look like it'll let us source it from there. So, but we can get the pings out anyway, and that works well because it still shows us what we need to see. And again, remember, we're not double natting here, right? So this address that we're trying to go to is not being natted here on this router. So let's go ahead and let's spice this up a little bit. Let's change it up, and let's go out to the ISP, and let's see if we can do, and we don't actually have, let me check that interface because we might. So we're on the ISP, so we're going to set it up for another loopback address. So show IP interface brief. Let's see what we've got here. So you can see we've got the one loopback address. Let's go ahead and go into global config, and I want to show you an example of what it looks like when we end up with that translation, when it's getting translated twice, so the outside global and the outside local are different addresses. So if I say do show run interface FA01, I think that's a slash, yeah. So we have some addresses that we could use, but we're not going to. So here's how we're going to do. Let's see how we're going to do this. Let me go ahead. Let's get a new loopback address. So interface loopback, and we'll call this loopback 1 because we're good with that. So I'm going to say IP address 209.165.203.129. Oops, .129, and we'll make it a /30. So do show IP interface brief. So as you can see there, we now have this this other address here, this 209.165.203.129, and let's see, or do we want to use an internal address? So yeah, let's use an internal address instead. So we'll say no loopback 1, no interface loopback 1, and so let's go ahead. We'll use we'll say loopback 172, and so we're going to say IP address 172.16.16.16. All right. So we're going to use an RFC 1918 address there, an inside local address, and we're going to go ahead and set it up to NAT. We're just going to create a pool. We'll have to add in some routing information here, but this should be pretty straightforward. So we'll just say IP NAT inside source static, and context sensitive help is gone. IP NAT inside source static, and so we'll say our inside address 16, and then we'll just pick one, 209, and this is where we'll use our 203. So 209.165.203.129, And now we've got the static NAT. So the problem is, right, that we don't have a route. When we try to get to this address, we don't have a route to get there. So on the branch router, and we'll test from the branch router. So if I were to say, we'll go into global config IP route. So for me to get to this network, and we'll say 255.255.0, or actually let's we'll keep it as the, what do we say, 129. So keep it as a /32 host route. I'm going to go out FA01. So the ISP router already has a route back to the branch router. I now have a route to that address that we're natting, and it says to go out FA01, and we have a NAT statement, a static NAT statement here. So if I say do show IP NAT translations, you can see we've got the inside local address to which it's being translated. So let's give it a try. What happens if I say do ping 209.165.203.129? And so we've got a routing issue, so it's having a problem. Oh, sorry. And let me source that from my loopback 0 address. So we're having an issue here with it getting back to us. Let me make sure. So do show IP route. Let's see what we've got. So there's the 203.129 static directly connected. So we're good there. Let's check the, and we do have a translation there directly connected. So it's getting to the 172, but then the 172 cannot find, and we're not able to reach back to the originator. 209.165. It should be 200.249, right? And that works. And so it's having a problem getting back to us. So let me see. Do show IP route 209.165 200 dot, and what are we going to be? 249. Yeah, directly connected. So that is good. Do show IP route 209.165.203 dot 120. Oops, 129. And let's do this. I'm going to change. Let me change that route, and I'm going to take it away from being the outgoing interface. So let's say do show run section route. So let's get rid of this out the fast Ethernet 01. I'm actually going to put the next hop IP in here. Let's see, copy and paste. And we're going to say the same thing, except we're going to put in here the next hop IP of 209.165.200.241. Do ping 209.165.203.129, and we're going to source it from loopback 0. And so we still have the unreachable. So let's say, let's trace it out and see what we get. So 209.165.203.129. So we make the hop to the 241, and then we continue. So we're kind of looping. Oh, I apologize. So we're looping. So what did I forget to do? As soon as I saw this, I was like, I know exactly what we forgot to do. So what did we forget to do here? And we forgot to do it over on this router. So remember, in the NAT setup, we're doing domain NAT, right? So what do I need to do? Interface FA01. And actually, hold on a second. Do show run interface, where it would have been FA01. Or do show run in FA01. Did we forget? Yeah, it's definitely not there. Do show run in loopback. So it's our, yeah. So loopback 1. Interface loopback 1. Or loopback 120, or what did we say? 172 is what we use. Sorry. Too many O's in there. Yeah, so anyway, what I'm trying to get to here is, we're running through all these typos, is I forgot to say IP NAT outside on the outside interface. I forgot to put the NAT domain statements on the interfaces. We had set the NAT up, and then I moved away from the router. So we definitely need to have the NAT interfaces, or we're going to see exactly what we saw, which is the traffic gets to the next hop, and then let's get into interface loopback 172, IP NAT inside, is that the traffic gets to the next hop, but it has no clue what to do next. And we left off the NAT statements, and so that was my problem. So let's go ahead now. Let's try the ping again, and there we go. So this is what we were trying to achieve. And let's see now, do show IP NAT translations. What do we have? And it did not do the double natting for us with the loop back, or wait a minute, 200, 249, 203, 129. Yeah, it didn't do the change for us. Maybe we have to do it using something other than the loopback address to get it to maybe go through the router. So I was hoping that it was going to give us a different outside local and outside global, but it did not, unfortunately. So again, we got the double NAT, or I should say, we got the natting to work there. However, it did not do what we expected it to do. Let's see, do we have reachability over to, so let's say do ping over to that email server, 209.165, 200.238. Let's double check that. Yeah, 200.238. Do we have reachability? What if I source it, SOURCE, from loopback 0 here on the branch router, and that works. Let's say do show IP NAT translations. And as you can see, we have no problem getting over to, to the email server. So let me go ahead and double check here. Let's make sure that that was everything out of the lab. And it was. And that is pretty much it. All right, so that is going to wrap up Lab 6-1, where we talked about domain NAT. And remember, this is not legacy NAT. This is not NAT that you should not be using. This is just simply NAT that deals with a different use case than you're typically used to seeing. And remember that NVI, or NAT Virtual Interface, that is the type of NAT you want to be using if you're trying to NAT between VRF interfaces. So again, it's not that NVI is a wholesale forklift replacement for classic/domain NAT. It's just simply dealing with a use case that classic domain NAT is not able to handle without some significant effort. Okay, so that is it, and I will see you guys on Monday.